Hi, welcome once again to the medical student in College of Medicine and College of Pharmacy second stage, to whom join us in the series of lecture on the physiology of cardiovascular systems. Today, lesson in the electrocardiography to know how to analyze rhythm and how to find the rate and what's the criteria of normal sinus rhythm. Just to remind you, the impulse starts in SA node and passes interatrial pathway and passes the AV node and then his bundle or bundle of his, then the bundle branch block to the terminal part to the Purkinje system, or Purkinje fibers. And as we know that the depolarization of the atrium gives the P wave, while depolarization of the ventricle gives the QRS complex, and repolarization of the ventricle gives the T wave. This is an ECG record. As we know that ECG are waves and interval and segment. This is the main wave, as we said, P wave atrial depolarization, while the QRS complex ventricular depolarizations, and the T wave is the ventricular repolarization. And the segment PR segment, which means the atrial that take the times. As we said, we that calculate it by second, millisecond, by small or big boxes. Atrial depolarization plus where is the delay, the impulse in AV junction. That's with the AV node and bundle of this. And this is give a more time for ventricle to be filling. While as we know, the natural pacemaker of the heart is SA node, is a dominant pacemaker with intrinsic rate to the 60 to 100 beats per minute. While AV node is backup. Backup is the second line. If the failure or something defect in SA node, this will be dominate the impulse with the rate of spontaneous and intrinsic automaticity or spontaneous discharge in 40, 60 less than SA node, while the ventricular is the cell as a backup pacemaker with rate, the lowest rate is 20 to 45. So we see that the spontaneous discharge on the could be in any part of this cell, but that the fastest is the SA node, the lowest in the ventricular cell. Also, in the ECG paper, we say there is a big boxes and the large boxes and the small boxes. The horizontal is a time, vertical is a millivolt. Every small box is 0.4 second, and the 5 boxes is 0.2 second. Well, we can say 200 millisecond. While vertically, every part, this small square 0.4. While every small square vertically 0.1 millivolt, totally 0.5 millivolt. So horizontally, one small box 0 second, while large box is the 0. While vertically, if small box 1.1 millivolt, sorry, this is 0 is removed, and 0.1, and the large box is 0.5 square. So the ECG paper, please remember that. We will discuss it when find the rate of how to find the heart rate in ECG record. This is the 3-second part, and this is 3 second, totally 6 seconds. What mean by every 3 seconds, 15 square large boxes, and marked by the vertical line. This is a vertical line. This helps when calculating the heart rate. Please remember it. The following strip are most marked, but all the 6 seconds long. We will discuss what mean by 3 seconds and the 6 seconds to find the heart rate. Please, 1 minute equal to 60 seconds. All we know that. So large box is 0.02. So 3 seconds, what if we divide it to the large box? So there is 15 boxes. Please remember that. Every 3 seconds is 15 box. It's coming from that. 3 seconds divide that the large box, so it is 50. 6 seconds, 60 divided by that the large boxes is 0.2, and that the result is that the 30 boxes. So that the second minute is the 30. We count 1, 2, 3, 4, 5, 6. This will be discussed when we find the rate. This is a simple mathematic, ideas. 60 seconds over 3 seconds, so 20 times. And 60 over 6, 10 times. That is we will find when to find the rate at the 3 second, what the number of boxes times 20. While that the RR waves between these boxes, 1, 2, 3, 4, 5, and for the 6 second number of R wave in the 30, we find it 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times 10, it's 90. So the heart rate is 90. If we find that the 3 second, 1, 2, 3, 4, nearly 5. By 20, nearly the 90, because it is the same heart rate. So step 1, calculate rhythm. We will step 2, determine how regular is the rhythm. Is regular, is irregular, is the irregularity is regular, or it's completely irregularities. As such, the P wave, shape, contour, is the present, and form, duration, and so on. PR interval, find that the duration of PR interval. QRS complex, duration and shape. It's normal, abnormal, wide, bizarre, and so on. So we will discuss how to find these in the strip or normal ECG, or the record of ECG, either normal, abnormal. First, calculate rate, determine it's irregular or not, assess the P wave, determine that the PR interval and QRS complex. We will start with the rate. What mean by heart rate? Heart rate is calculated as a number of times the heartbeats per minute. If you remember, when we find the cardiac output, we say stroke volume time the heart rate is the beat per minute. It's usually measured ventricular rate. That's the number QRS complex, but can refer to atrial rate when count the P wave. The method chosen to calculate heart rate varies according to the rate and regularity on ECG tracing. We will find what mean by rate, if it's rapid or slow, and it's regular or irregular. So if the regular, method 1, if the heart rate is regular, the rhythm can be quickly determined, very quickly, by counting numbers of large graphs boxes between RR waves. We find 2 RR waves, count the large boxes, then divided by the 300. So we will find that the beat per minute. The rate of the first 6 large boxes can be easily memorized. Remember that 60 seconds divided by 60 seconds equal 1 minute divided by the 0.2, it found 300 large square. So that the 60 seconds divided by the large square is the 0.2. The number of square is the 300. That's why we'll divide by 300. What I say, if it's regular, so count the RR wave between the boxes between RR wave. This is RR wave, the boxes between them are large boxes divided by 300. So if it's 1 box, so the rate is 300 beat per minute. If 2 box divided by 2, 150 beat per minute. If the 3 boxes is divided by 10, it's 300 beat per minute. 75 if that the 4. If that the 5, rate will be 300 over 560 per minute. Now this is the rate here in the RR wave, count the large boxes 1, 2, 3, 4, 5, 6. 300 divided by the 5, 300 divided is the 60. So it is easily, if the regular, take RR wave, count the large boxes between them, divide 300. It will take the rate as quick as it. So this is log to this is the R wave, and take R wave, number of boxes. If RR wave, one box, so the rate 300. If two box, 150. If the three box, 100. If the four box, 300 over 475. Is the 5 is the 60. If the 6 boxes is the 50, and so on. So find R wave that land on the bold line. This is count the numbers of large boxes to the next R wave. If the second R wave is one large box, so the rate 300. Two box 150, and so on. This is the heart rate when the rhythm is regular. So look to that this is ECG. If we find that the count numbers of boxes 1, 3 RR wave, number 1, 2, 3, and something more than 3, 2. So divided by 3, 100. And the minus 2, that's a 90, nearly a 90 beat per minute. So if it's one box, 300, two box, 150, and so on. This is the rate first method on easy method and quick method, and use it usually in a clinical practice. But if irregular, there is some problem. So memorize the sequence, one square between RR 300, 150, and so on. So this interpretation, the rate approximately 100 and minus the two boxes, so it is 95 beat per minute. This RR wave, number of large boxes. Okay, this is the table. How many large boxes divided by 300, 300, 150, and so on until reach the lowest. Great. Second method, the counting small boxes, not large boxes. If the rate is very rapid, say it's 400, 600, or 450, sometimes we reach so take small boxes and divide it by 300 by 5, so it is 1050. It's easy. And the 60 minute divided, previously divided 0.2, now 0.2 is the 1500. If there are there count small boxes in the very rapid heart rate. If there is a 6 small boxes, the rate is the 1050 divided, so it is 250, and so on. If there are 10 small boxes divided by, we usually use the large boxes. But if it's so rapid, you just use small boxes. This is the exceptional. This number of small boxes divided by the 1000 and the 500, we will find the rate like that in the table. Now come to if the rhythm is irregular, between RR wave is coming 2 small box, other RR wave 3 small box, other RR wave 4 small box. So how to find that? So to find that, take a 3-second or 6-second strip. As we said, 3 second have 15 small, big square, and 6 second have the 30 large boxes. Count number of RR wave in 6 second time by 10, or 3 second time by 20. 3 second we usually in a rapid take a 3 second, count in irregular. In a regular we can use it, but for a rapidly in clinical use the first method by large boxes. So count 1, 2, 3, 5, that we count the large boxes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between the RR waves until 15 boxes. This is 15 boxes, 3 seconds, time by 20. 1, 2, 3, 4, 5 by 20. So it is 100 minus some small, so it is 95. My small square, which is 5 feet, so it is 95. If we take a 6 second, count 30 big square, large square, count the RR waves, time by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 5, 10, 90 plus 5, so it is 95, the rate. So first method, which is easy, by large boxes divided number of large boxes between RR wave divided by 300. While if a very fast rhythm, very fast heart rate, and we count small square and divided by 1500, which is least used, this method. Other methods, if irregularity, take for 3 seconds, count 15 big square, count number RR wave, time by 20 for to be easy. So interpretation, the rate is about 90. Please, I just remind you, 1 minute is 60 seconds, so large square is that the 0.2, so 3 seconds, 15 square. Time by 20. Of 6 seconds, time by 10. Usually we use a 3 second, 15 square, number of RR wave, time by 20 if it's irregular. I think this is easy. In irregular heart rate, 3 seconds. RR wave, number of boxes, RR wave times large boxes, time by 20, or that the 6 minute times by 10. We use usually for 3 seconds for each. And this is discuss it. How determine the irregularities? Just now we know how to determine the heart rate rapidly when take ECG. How to determine the regularities? So look at the RR wave. If the distance between them equidistance, this means the regular. If the distance vary from there to there, it's irregular. So this is the regular equidistance. If we count number of big square, 1, 2, 3 plus 2. This is 1, 2, 3 plus 2. 1, 2, 3 plus small square. This is two small square to 1, 2, 3. So it is the regular. Look at RR distance using calibers or marking on pen or paper. Anyway, I'll count that the number of large and small square boxes and see that if regular are the equidistant, the same distance apart. Occasionally irregular. If it's irregular, we see this is irregular, it's repeated, so it is called regular irregularity. If it's irregular, it's not repeated. It's not like any way, so it's called irregular irregularities. We'll find that when discuss the rhythm and atrial fibrillation and so on. So interpretation, this is regular. Now we have two ways to find the rate and regularities. Assess the P wave. Third way, look to the P wave. Every P wave in sinus rhythm, atrial depolarization followed by QRS complex. P wave, QRS complex. P wave, QRS complex. So it is this is the regular and the sinus. P wave, QRS complex. P wave, QRS. The impulse passes in normal conductive pathway. We will discuss it several times. And then look to the P wave. Is similar in the same strip, in the shape and duration, so it is normal. Look to that it's preceded by QRS complex, followed by QRS complex, and it's normal indifferent on the same shape, on the same morphology, and same duration, so it is normal P wave. So are the P waves, do the P waves all look alike? Yes. Do the P waves occur at the regular rate? Yes, we can count the boxes between P wave and P wave. Is there one P wave before each QRS complex? Yes. So this is a normal P wave. Please look to that every P wave QRS complex and the P wave equal distance between the P wave. Every P wave QRS complex look like the same. This is a normal P wave. So we have three things in the normal P wave with the one P wave for every QRS complex. This means it is normal impulse conducted from SA node to the atria and AB node to the ventricle. And for a time being, at the end of lecture, the student must know how to calculate the rate and give idea is the rhythm is normal or abnormal. The rate used as the 300 divided the number of the number of the boxes between two RR wave, or if it's irregular, take 3 seconds, 15 big boxes, and count the RR wave times by 20. And then look to that every P wave, to assess irregularity, every P wave is that followed by QRS complex and RR wave are equidistant, so it is regular. Now to P wave, look to the shape, every P wave followed by QRS complex and duration, and the distances between P wave equal, so it is normal P wave. Now come to the interval. Look at from the beginning of P wave to the beginning of QRS complex. This is what called PR interval. Normally, as we said, 3 small square to 5 small square, one big box. So it is normally 0.2, 0.12 to the 0.2 second. We can say 120, 200 milliseconds. That mean 3 small boxes to the 5, maximum 5 small boxes, 3 to 5 boxes. Interpretations is the second. This is a normal PR interval. The fifth thing is that the duration of a QRS complex, beginning from the Q to the end of S wave. Usually this duration of one small box to the 3 small box, 0.04 to the 0.12. So if it's more, we say it's wide. This is the duration of a QRS complex. Really, if we look to the QRS complex, it's look alike, the shape or different, and its a duration normal. If a QRS complex and preceded by P wave, this is important, and then calculate the duration of a QRS complex. It is 2 small squares, so it is normal. For a time being, every student at the end of this lecture, he must know how to calculate the rate, and if the regular by looking to P wave and the QRS complex and distance between RR wave, and if look to if the P wave normal, that is P wave look alike, and followed by QRS complex and distance between P wave is normal, and then look to the duration of PR interval, which is 3 to 4 to 5 small square, and the duration of a QRS complex. And the summary, the summary of our lecture. This is we calculate the rate by large boxes 1, 2, 3, And the R wave, look, this R wave, this R wave. 1, 2, 3, something minus 2, so it is not 300. 300 divide 300 minus these 2, about 10, so it is between 9 to 95 beats per minute. Is the regular? Why? Why, if we measure the distance between R wave, it's equidistance, and every QRS complex preceded by P wave, so it is regular. And is the P wave normal? Yes, look alike. Every P wave followed by QRS complex, and the duration is normal. If we measure the distance between P wave, it looks the same as distance between other P waves, so it's normal. And the PR duration, if we measure it, it was found 3 small square. Point from there to there is the 3 small square, then within normal. QRS complex, this is 2 small square, so it's normal. Look, find the rate, and it's regular or irregular, P wave, PR interval, QRS complex. Any ECG is coming by this criteria. Rate between 60 to 100. It's a regular, normal P wave, normal PR interval, normal QRS complex, duration and shape. This is what called normal sinus rhythm. What mean by it's coming from SA node, passing normally in the atrial pathway, then to the AV node, then to the ventricle, a bundle of his ventricle in normal pathway. This is what called normal sinus rhythm. So normal sinus rhythm, find the rate for every ECG. At the end of this lecture, the student must know rate, regularities, P wave, PR interval, QRS complex. If we find these all normal, this is a normal sinus rhythm. See you soon in the next lecture.